Hi, how are you doing today?
I'm doing well, thank you.
And tell me your name and tell me a little about your project.
My name is Kit S. Thorne, and I am a physics researcher at the Laser Interferometer Gravitational Wave Observatory, and we are studying, as in the name, the existence of gravitational waves.
Hey, and tell me what you guys were trying to find.
We were trying to prove, or rather find tangible evidence for the existence of gravitational waves, a theory proposed by the Albert Einstein, of course, in the early 1900s. Initially, with this theory, there was no tangible evidence for its existence, so we set out to prove its be true.
And where did this project or experiment occur?
Well, the initial observation took place on Earth, at least, in Hanford Site, Washington, which is where one of our buildings is located, but the actual event itself, as we observed, took place almost a little over 1 billion light years away, specifically around two joining black holes.
Yeah. And what other significant events were happening around the world at this time?
There were several international crises going on around the world during this time, which was 2015 to be specific, although we did release the results of our report in 2016. We started the initial observation this time in 2015. Things such as the European refugee crisis and the Saudi invasion of Yemen, to name a few world events, but we also had some significant events going on in the physics world, such as the Hanford Collider having its second longest run, and the 100-year anniversary of Albert Einstein's theory of relativity.
Great, and who else was involved in this project?
There were several big names involved in this project, such as Jekta Gersel, Alex Abramowitz, and Ronald Drever, to name a few of the bigger names in the physics world, but there were also many more lesser-known physicists participating in this project. I think a total of about 14 other people.
And tell me a little bit more about your specific role in the project.
Well, I'm one of the founders of the LIGO Institute and we were all working on the observation of finding gravitational waves throughout the universe. And I, like many others, was a data collector. So I would observe phenomenons across the cosmos and collect and interpret the data we got from these pictures.
And what impact did you see on the physics community?
Well, the detection of gravitational waves is actually fairly revolutionary. Previously, before we confirmed the existence of this theory, we were only able to detect bodies in space through electromagnetic waves. And the problem with this is, to detect electromagnetic waves, an object in space has to be emitting electromagnetic radiation, and not all the objects do that, and some objects will obscure other objects with how powerful their radiation is. But every object in space has some sort of mass, and if it has a mass, it can create a gravitational force around it, and through the creation of this gravitational force, we can detect the gravitational waves, which makes it much easier for us to detect different bodies in space.
And what exactly are gravitational waves?
I'm so sorry, I didn't realize I never explained it, but gravitational waves are exactly as they sound. As I said in my previous answer, all objects in space have a mass. And with a mass, you can create a gravitational point. So every object that carries a mass has some sort of point or force of gravity surrounding it. And gravitational waves are the result of the creation of this gravitational force by these objects within the fabric of space-time.